So I want to show you, this is a 4x4. It's probably a good idea to do it with a computer because it's pretty much um, very difficult to not make some simple mistake. So what I'm gonna do is I'm gonna try to define this in Matlab, and first I'm gonna see if it's invertible by taking the determinant. And if the determinant of this is gonna be 0, then I know that this is a singular matrix and it's non-invertible. But if it is invertible, then we're gonna use the adjoint theorem to find its inverse. And then I'm gonna check it with the inverse function in Matlab. So let's do that. Matlab here. I'm gonna take this stuff out so that you guys can enjoy a better view. And let's say that this is exercise 13. And the first thing I'm gonna do is I'm gonna clear all the variables. So clear all. Okay. Now the second thing I'm gonna do is gonna define be defining my matrix. And I'm gonna call it matrix A. And it had in the first row 0, -1, 1, and 4. Then I put a semicolon to go to the second row, 3, 2, and -2 and 1. Then I go put a semicolon again, go to the third row, 0, 4, 0, 1. And the last one is 1, 0, -1, and 1. Okay, then I put a semicolon because I don't want to output it. Let me check that I put all the numbers correctly. 0, -1, 1, and 4. 3, 2, -2, and 1. 0, 4, 0, 1, and 10, -11. Okay, so now what I'm going to do is I'm going to check the determinant. Finding the determinant, we do that with the command det. And we've looked that the determinant is 27. So we know right off the bat that this is invertible because the determinant is not equal to 0. We'll assign it a variable d so that we can use it later for the adjoint theorem. Using the adjoint theorem, first we find the adjoint. And there's a neat command in Matlab, which is actually adjoint. It's nice how Matlab calls everything with the proper name. And we want to find the adjoint of A, and we'll indicate it with this variable name. Then what we want to do is we want to find the inverse of A with the adjoint theorem, which is basically 1 over d, 1 over the determinant of A times the adjoint. And that's going to be our answer. And then we want to check that the answer is indeed the inverse. And so we can use the inverse function to check it. And lo and behold, we get our adjoint matrix. And we notice that if we apply the theorem, we get the same result as the inverse function in Matlab. So we're confident that our answer is correct. Well, I hope you enjoyed the video and that you learned something. And I'll see you next time.